Hi guys, welcome back to my channel. In this session, where I will walk you through on paper 1 today, and the question I will solve in this paper 1 is the question on assembly language, and that is question number 3b, so that those who have challenges and difficulty with assembly language and how to complete the trace table can understand from this question. Okay, let's solve this question. So before you solve this question, I expect you to understand what registers are, what is an accumulator, an index register, and the assembly language instructions. So in your exam, the assembly language instructions will be given to you like in this question. The instructions will be given to you and the explanation on what the instruction is for. For example, LDMN, this is an immediate addressing. It loads the number n to the accumulator. So wherever you see this hash followed by a number, that number is a decimal number. Okay, wherever you see hash followed by a number, it is a decimal number. So let's take, for example, we have LDM hash 6. That means it loads 6 into the accumulator. Like it does it immediately. It doesn't go to an address before it does that. LDD address. So this is direct addressing. So this loads the content of that address. Okay, this loads the contents of that address to the accumulator. So let's take, for example, you have LDD205. If address 205 has value 10, it loads 10 into the accumulator. Okay, LDI, the address to be used is at the given address. Okay, so this loads the content of the second address to the accumulator. So I expect you to understand, to have learned all these assembly language instruction. So because we'll be using this instruction to answer this question and completing this trace table. So if you don't understand what these instructions are, so the prerequisite to this question solving is to first understand what an accumulator is, what a general purpose register or registers are, and special purpose. Understand the program counter, the memory address register, the current instruction register, and so on and so forth. So that will enable you to be able to solve question 3A. And once you understand that, understand the assembly language instruction, like I said, because I won't be able to explain one by one, but you use this table to answer the question, and that is exactly what I will do now. So please sit tight and give me your attention so you understand. Okay, while doing this, this is the question. Okay, so the current contents of the memory and selected values from ASCII character set are shown below. So this is the address, this is the instruction for each address, this is the ASCII table for the selected codes only. And the question says complete the trace table for the program currently in the main memory. Okay, so I can write, so I will use this Word document, it's the same thing. Then whatever answer I'm going to answer, so I will answer it in this table. So that means that I will follow the question from here and follow the instruction from here. So whenever I see the question, so I go to this instruction to understand how to solve the question, then I solve it in this Word document. So let's start. So the first instruction states for address 200, LDD325, address 200. So that means for the instruction address, it is so the instruction address is 200. Then I have it here as 200. Okay. What does the instruction state? LDD365. If you don't know what LDD365 is or you have forgotten, so the table has been provided in the question. It says LDD address. So that means 365 is what? Is an address. So what does LDD address do? LDD address loads the content of the location to the what? To the accumulator, the content of that address to the accumulator. So what is the content of 365? The content of 365 is 1. So it loads 1 into the accumulator. So that means I have 1 here. So 1 has been loaded into the accumulator. I hope that is understood. So LDD 365 is done. So let's go to address 201. Then address 201. 201. It's as simple as that. CMP366. What does CMP366 mean? In case you don't know or you've forgotten, just go to the table. This means CMP address. What does CMP address mean? It compares the contents of accumulator with the content of address. Compares the content of accumulator with the content of address. So what is the content of an accumulator? 1. What is the content of address? CMP366. What is the content of address? 366 is 3. So it compares 1 and 3. Compares 1 and 3. So what is it comparing? It's comparing if they are the same or not. Okay. So that means at 201, nothing will be written. Okay, because it is just a comparison. So let's go to the next one, 202. Address 202. So why is it that I didn't write anything in 201? Because it's just comparing. Is that understood? So 202, JPE 209, if you don't know what it is, go to the table and check for JPE address. What is JPE address? Following a compare instruction, that is after an instruction has been, after some two values has been compared, or after the compare instruction, jump to address if it is what? If the comparison was true. Jump to this address, that is JPE means if when you compare, if it is the same, if that value is the same, go to that address. That means that JPE 209 means go to address 209. Can you see address 209? Go to address 209 if that comparison was true. So let's check. 1 and 3, is the comparison true? The answer is no. So will it jump to 209? The answer is no. It will not jump to, because that comparison is not true. So it doesn't jump to 209. So that means we now write nothing there. Nothing is written there. So we'll go to the next address. 201, nothing is written because it's just a comparison. 202, nothing is written because it is what? It is not true. Okay, so it doesn't go to 209. So what is the next thing? It goes to 203. So address 203. Okay. So what does address 203 says? It says ink accumulator. If you don't know what that is, go to the table. Ink accumulator, add 1 to the content of the register. Whatever register that is written there, whether accumulator or what, or the index register. So ink accumulator means add 1 to the content of accumulator. If it is ink IX, it means add 1 to the content of IX. So this address 203 says ink accumulator. So what is the content of the accumulator? The content of accumulator is 1. So that means adding 1, it becomes 2. I hope this is understood. It becomes 2. When that becomes 2, then 204. We go to address 204. Okay? Address 204 means store 365. And what does store 365 means? STO365. If you don't know, just go to the table. Okay, the table is provided for you in the exam. Store address. Store content of accumulator to the address. So the content of accumulator is stored to the address. So that means that store 365 means store the content of the address of the accumulator to address 365. So what is the content of accumulator? 2. So we store it into what? Into 365. Is that understood? So that means the value of 365 is no longer 1, it is now 2. So I hope this is understood. Now the next, MOVIX, that is address 205. Okay, then you write 205 MOVIX. If you know what that is, go to the table. MOVIX, MOV register means move the content of the accumulator to the register. Move the content of the accumulator to what? To that register. So MOVIX means move the content of accumulator to the register. Okay. So MOVIX. So what is the content of accumulator? It is 2. Isn't it? So move it to the register. So that means register now has value 2, no more 0. Okay. Now the next we move to what? 206. 206. What is 206? It says LDX365. LDX365. Let's check. What is LDX365? LDX address. It means form the address. It formed the address from address. It formed the address from what? From this address. It forms an address. So the content of the index register. What does it mean? It means copy the content of this address to what? To accumulator. So what does that mean? Let's take, for example, LDX365. Okay. LDX365 means the address is 365. We are forming another address. Is that understood? So that means that the content of the index register will be added to that address. I hope this is understood. The content of the index register, can you see? Address plus content of index register. What is the address? Address is 365. What is content of index register? Can you remember? Content of index register was what? Was 2. So 365 plus 2 is what? Is 367. So now that LDS 365 means 365 plus the content of index register. Is that understood? 365 plus content of index register, address plus content of index register, which was 2. That becomes 367. So you now copy the content of 367 to the accumulator. The accumulator address is 367. Is that understood? So we copy the content of 367 into the what? Into the accumulator. So at address 206 means copy the content of 367 into the accumulator. So what is the content of 367? It is 65. So we copy 65 into the accumulator. I hope this is understood. So that is 206. So let's move to 207. Now 207, out. What does out means? Out means output to the screen the character whose ASCII value is in what? Accumulator. So what is 65? A. So that means we output to the screen. So 207, we output A. You can see output. We output A because 65 is what? A. Is that understood? Because out means what? Output to the screen the character whose ASCII value is stored in the what? Accumulator. Is this understood? So that is 207. Now 208. 208. What is the instruction on 208? JMP 200. What is JMP? Jump to the address. So what address are we jumping to? Address 200. So what is 200? So we jump into this address. Okay. So 208 means jump to address 200. Is this understood? So nothing will be written in 208 because we're just jumping. Is that understood? So jump to address what? 200. So which is exactly what we've done. So we move to 200. So we jump it to address 200. I hope this is understood. So that means we're starting again. Okay? That means we're starting again. Now, load 365. What does that do? It loads the content of 365 into the accumulator. What was the content of 365? It is now 2, isn't it? So we write 2 to the accumulator. Okay? Now, what is the next thing? CMP366. We compare that value with the address of what? 366, right? So we compare 2 and 3. Are they equal? That is address 201. Address 201. When you compare 2 and 3, are they equal? The answer is no. Then what does 202 means? So you don't write anything. So 202 means if it is equal, jump to what? 209, that is you end. Of course, it is not equal. So we don't jump to 209, we just go to 203. I hope this is understood. We go to 203. Now, when we get to 203, what does it say? Increase the content of accumulator by what? By 1. So accumulator was 2, right? When you increase by 1, it becomes 3. Okay? Now that that is 3, what is the next thing? Store 365. What does this mean? STO365. Can you remember what it means? So that means you store the content of accumulator to that address 365. Okay? So that means that, is that 204? Yes, 204. So 204 means store the content of our accumulator into that address. And remember, address 365 is this, right? So we store 3 into 365. Is this understood? Okay, good. Now, 205. 205. What does that state? MOVIX. Can you still remember what MOVIX is? So it means move the content of accumulator to the index register. So what is the content of accumulator? 3. So you move it to the what? Index register. So this is the index register. So we move this to the index register, which is 3. So that is 305. Okay? That is 205 rather. Now 206. 206. 206 LDX365. Now, what does this mean? This means that you add the content of index register to 365 and copy that value in that new address to the accumulator. The previous address was 365. So when you say LDX, it means add the content of what? Of the index register into this. So what is the content of index register? That is 3. 3 plus 365 is what? Is 368. So you now load the content of 368 into the accumulator. So what is the content of 368? 66. So we load 66 into the accumulator. I hope this is understood. That is the content of 368. Okay? So that is 206. Understood? The next thing, 207. 207. So 207, the instruction is out. That is, you output the ASCII value of 66, which is now what? Which is now B. So B will be outputted. So that is 207. Okay? Now, after 207, now 208 states jump to 200. That is 208. So 208 means jump to 200. Now we are now at 200. So what is 200 doing? Load 365. Load the content of 365 into the computer. And the content of 365 is what? Is 3. Okay? So now that 3 has been loaded, compare it with what? With the content of 366. So what is the content of 366? 3. When you compare, are they the same? The answer is yes. Now that they are the same, so 201 means compared. 201, we've compared, they are the same. So the next 202 is now what? Jump to 209. 229 means what? Jump to 209. So when you jump to 209, 209, and that is all. Nothing will be waiting because that is the end. So this is the solution to question 3B as regards to what? To the assembly language instruction. I hope this is understood. If you have any question, you can place it in the comment section. Now, the next question now states, the accumulator currently contains the binary number. So this is the what? This is in number in the accumulator. It is binary. Write the content of the accumulator after the processor has executed the following instruction, LSL2. Don't forget, like I said earlier, you must have understood the instructions before you solve this question, okay? So what does LSL2 means? LSL number. It means bits in the accumulator are shifted logically n places to the left. Zeros are introduced on the right-hand end. So that means LSL2 means shift the bits in the accumulator 2 places to the left. Is that understood? So that's what that is saying. So let's go back to the question. LSL2 means shift the content in the accumulator 2 spaces to the left. So when you shift it 2 spaces to the left, so this will be out, this will be out, isn't it? So I have this as 1, 1, 0, 1, 0, 1. Okay, so the instruction now states that zeros are introduced to the right hand end. So that means to the right hand end, you just replace the remaining spaces with what? With 0. It is as simple as this. It's as simple as this. The next question. The accumulator currently contains the binary number 00110101. Identify the mathematical operation that the following instruction will perform on the content of the accumulator. So what mathematical instruction will this perform on the content of what? Of the accumulator. So LSR3, can you still remember what it is? LSR3 states bits in the accumulator are shifted n places to the right, zeros are introduced on the left. So you shift it 3 places to the right, zeros introduced to the left. But that is not what the question is saying. The question did not ask us to perform this expression. It's just asking what mathematical operation, okay, will the instruction perform. Is that understood? So how do we do this? So before we can identify the mathematical operation, let's do this bit shifting first. That is the first thing we need to do, okay? So how do we do that? Now, very simple. LSR3 means move this bit to the right 3 places, right? Then replace the left hand side with what? With 0. So that when we move to the right 3 places, this is out, this will be out, this will be out, right? So that means I have 0, 1, 1, 0, 0. Then you replace with 3 zeros. 1, 2, 3. Okay? Now, so let's convert each of them to base what? To base 10. Okay? So I understand the mathematical operation. If you convert this to base 10, what will you get? So let me, in case if you have forgotten, to convert to base 10, I start with this 1, 2, 4, right? 8, 16, 32, 64, minus 1 to 8, isn't it? So this becomes 1 plus 4, right? 1 plus 4 plus what? 16 plus what? 32, isn't it? And when you add this, it gives us what? 53. Okay? Now, if you take a look at this, this becomes what? 2 plus 4 is equal to what? 6. What is the relationship between 53 and 6? If you divide 53 by 8, you will get 6 remainder. Okay? Because 8 times 6 is what? Is 48. So 49, 50, 51, 52, 53. 6 remainder 5. So that means that when you divide 53 by 8, the whole number is what you have here as 6. So that means that when you divide this binary number by 8, the whole number is what you get when you do LSR 3. When you shift this number, this bit, to the right 3 times, you get the whole number when you divide the binary by 8. So that is the answer. Is that understood? So that is the answer. So to answer this question, you just write the number is what? Divided by 8 and only the whole number is what? Is retained. Is this understood? Okay, good. So that is the end of this question. If you have any question or anything you want to clarify, you can ask in the comment section. I hope this is well understood. Don't forget to like and subscribe to our video so you can enjoy more content. Thank you so much.